Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 9 from the May-June 2023 International A-Level. This is the Cambridge 9709 paper 1 variant 1. And this question here is under the topic of differentiation and specifically under the category of what are called related rates of change. So we're told about water being poured into a tank at a constant rate of 500 centimeters cubed per second. The depth of water in the tank, T seconds after filling starts, is H centimeters. When the depth of water in the tank is H centimeters, the volume V centimeters cubed of water in the tank is given by the formula V equals 4/3 times in brackets 25 plus H cubed minus 62,500/3. A bit of a strange formula, but anyway, it says find the rate at which H is increasing at the instant when H equals 10 centimeters. So basically, they've given us a typical type of problem here involving rates of change. So in the question, we can see that they have given us something. They have told us that water is being poured into the tank at a constant rate of 500 centimeters cubed per second. Okay, 500 centimeters cubed per second. That is like the rate of increase of volume in the tank. Okay, so they gave us a rate of change, which is, we can call dV dt, the rate of change of volume with respect to time. And they told us that it's going into the tank. That means it's increasing the volume of the tank. So it's positive 500. Okay, that is the rate of change of the water in the tank, of the volume of the water in the tank, increasing by 500 centimeters cubed per second. So they've given us that. And there's also something that they always tell us to find. So that'll be in the question part here. As we can see, it says, find the rate at which the height is increasing. Okay, so they've asked us to find the rate at which the height is increasing. Now, here they didn't tell us, with respect to what. So generally, when it says the rate of increase or rate of decrease of something, it means with respect to time. So basically what they want us to find, okay, is dH dt. So there's always something given, a rate given. This is the given rate. And this is the rate that we have to find. Okay, we have to find the rate. This is the rate we have to find. All right, so there's always a rate that's given and there's always a rate to find. And we have to try to combine them together with the formula they give us in order to find what we need to look for. So we're looking for dH dt, okay, when H is equal to 10. So we write down what we have to find and we make that equal to, so we put equals and then we always write down what they gave us. So dH dt is equal to dV dt. Now we have to multiply this and think about the chain rule in such a way that we will be left, when I multiply it by something, we'll be left with dH dt. So the first thing we realize is there's no V in what we have to be left with. So the dV has to be cancelled out. So there's going to be a dV over here. And we know that we have to introduce a dH here. There's no dH there. So I'll put dH like this. This will cause us to get rid of dV and we're left with dH dt, which is what we have to find. So this is what we have to try to deal with now. So I know the value of dV dt is 500. So I know that part. I've got to think about how to find dH dV. Okay, how do we find dH dV when H equals 10? Okay, dH dV. So to find dH dV, what we could do is we can take our formula, which is V equals 4/3 times in brackets 25 plus H to the power of 3 minus 62,500/3. And what we can do is we can find dV dH. We can differentiate this with respect to H, and the reciprocal of that will be dH dV. So if we differentiate this with respect to H, we're going to multiply both we got this bracket raised to the power of 3. The variable H is inside there. This is a constant. The constant is going to become 0 anyway. When you differentiate, constant becomes 0. So I'm going to multiply by 3. So I have 3 times 4/3. So multiply the coefficient by the power, and then the bracket, you reduce the bracket by 1. And then you reduce the power by 1, then you multiply by the difference of what's inside the function, which is just going to be 1 anyway. So these will cancel out. So we can say dV dH is equal to 4 times 25 plus h squared. Right, that's dV/dH. Now what we need is the HdV. The HdV is basically the reciprocal of this. Okay, so if you want to find the h dt, okay, you got dV dt, which is 500 times 1 over 4 times 25 plus h squared. Okay, so this will simplify. The 500 and the 4, that will give us what? I think is that 75? Okay, just we can make sure. 500 divided by 4 is 125, sorry. That's going to be 125 over 25 plus h squared. That is now an expression for dH dt. Okay, now they want to find dH dt when the height was, or the depth, h stands for the depth, was 10 centimeters. When h was 10 centimeters, when the water is 10 centimeters deep, we want to find the rate of change of the depth. So we're going to replace the h here with 10. So when h equals 10, the rate of change of the depth is 125 over 35, or 25 plus 10 squared, which is 125 over 35 squared. So we're going to do 125 divided by 35 squared, and that gives us 5 over 49. 5 over 49. If you want to write it in decimal form, then we can just find out what it is as a decimal. So yeah, 0.10204, 0.10204, dot, dot, dot. So we can say to 3SF, we're left with 0.102, and this is in centimeters, is it meters? Centimeters per second. Centimeters per second. Centimeters per second. So there we have the answer to this question. Okay, so that concludes this question, part A, and we're going to go on to part B. Now, part B says, at another instant, the rate at which h is increasing is 0.05 centimeters per second. So they're saying at some other time, some other point, the h dt has a value 0.075 centimeters per second. So we want to find the value of v at this instant. Okay, so we need to find the value of v when the rate of change of the height is 0.075. Now we already know what the dH dt is. Okay, sorry, we already know what dV dt is. Okay, and dH dt is in terms of a formula. We've got a formula for dH dt, which is 125 over 25 plus h squared. Okay, that's dH dt. Okay, 125 over 25 plus h squared. So that's a formula for dH dt. Right, so what we'll need to do here is we need to find what the value of h is, okay, when dH dt is this amount, when it's equal to this. Because the value of h is changing as water is going into the vessel. So we want to find what the volume is at the point when the rate of change of the height of the water in the vessel is 0.075. So if we can find the value of h, okay, when the rate of change of height is equal to this, okay, then we can find the value of h to put into here. So we've got dH dt, we have to just equate it to this now. So we have 125 over 25 plus h squared equals 0.075. If I rearrange this, I have 125 over 0.075 is equal to 25 plus h squared. If I solve this, I'll be able to find the value of h at the point when the dH dt is 0.075, and that value of h, I can put it back into this formula to find the volume at that same point. Okay, so now what I'm going to do is I'll find out what this is first. So I have 125 divided by 125, whoops, too many, 125 over 0.075 Okay, that gives me 5,000 over 3. So 5,000 over 3 equals 25 plus h all squared. Now what we can do is we can square root both sides. So I can say that, let's leave it in this exact form for now. 5,000 over 3 is equal to 25 plus h. So therefore h is equal to this minus 25. So I'll put minus 25 plus the square root of 5,000 over 3. So that will give us the value of the height at the point which we need it. So let's put this into the calculator and see what it gives us. So we're going to have the square root of the answer. Okay, and we're going to take away from this 25. Okay, so that gives us 15.824. Okay, I won't write it like this. 15.825, just to, or 8248. Write it to more accuracy than read. 8248 ... So that's the height when the HGT is 0.075. Now we have to find the volume when the HGT is 0.05. So we're going to take this formula, which I've copied from the other page. This is the formula they gave us for the volume. And now I want to find the volume when h is equal to this. So I just replace h with, in this formula, I replace h with this value here. So volume is equal to 4 over 3 times 25 plus 15.8248. Okay, and this bracket is cubed minus 62,500 over 3. So that should be our answer. So let's see what that gives us. So I've saved this answer. This is the last answer in my calculator. So it's actually, when I press answer now, that will come up. So I'm going to just put 4 over 3. Then I'll put bracket. I'll have 25 plus the last answer, which is what we need, close bracket to the power of 3, and then minus 62,500 over 3. And that should give us our correct answer, which is 69,888.50889. So 69,888 point, what was it last part? 5089, 508, it goes on like this. So now this answer, of course, we should round. It's not an exact answer. We should round it to 3 significant figures. So if we stop at the third significant figure, that's going to become a 9. That's going to become a 10. So it's going to become basically 70,900. Okay, this is closer to 3 significant figures. It's closer to 70,900 than it is to 69,800. That's right. So that becomes, no, it's just going to be 60. What am I talking about? Sorry. That's just going to become a 9. I don't know what I'm talking about there. Sorry. 69,900. Okay, 69,900. Does it say to the nearest anything? Nope. So 69,900. And that's the volume, which is in centimeters cubed. Okay, I don't know what I was doing there. Sorry, a bit tired today. Yeah, this becomes a 9. If this was a 9 and it would become a 10, then you'd carry on. It would be 70,000. This third significant figure is this number here. So it increases by 1 because this 8 becomes 9, and you fill the rest with zeros, and you stop there at the decimal point. So the volume is 69,900 centimeters cubed. And that's the answer to part B. Okay, I hope that was clear. Other questions from this particular paper can be found in the playlist, which will appear at the top of the screen after the video, or towards the end of the video. You'll find other questions from the topic of differentiation in general, and from P1 of Cambridge. You'll find that in the playlist over here, and questions dealing with related rates of change from, in specific. You'll find specific questions on those in the playlist over here, and you can subscribe to my channel by clicking on the link at the top. Thank you for watching, and see you soon.